So we have a graph, and we would do an Oizerga on that right off the bat. Velocity in normal units, time in normal units. So if the question's about velocity in time, we will just read it off the graph. The gradient, delta V over delta T, is the acceleration. And the area, V delta T, is the displacement, delta X. And we see there are these two bodies behaving like this with a constant velocity. Then the velocity changes, and it's constant again. This one has constant velocity, and then that changes again. That changes, and the two have the same velocity. That suggests in this situation that there's a 4 kilogram object, a 2 kilogram object. One is heading in a positive direction, one is heading in a negative direction, that they collide and they move off together in the same positive velocity. So the two are coming together, they collide, and when they collide, they move off in the positive direction because the velocity is positive. So let's see what the scenario tells us. Experiment with a 4 kilogram, initial speed of 6, 2 kilogram, initial speed of -3, toward each other and collide. Creates the velocity time graph. Positive direction is to the right. Which of the following are true regarding the data in the experiment? Both objects always travel in the positive direction during the experiment. That's false. This one has a negative velocity to start. So that's just off. Kinetic energy is conserved during the experiment. Well, if these things stick together, we know they collide. It doesn't say that they collide, but we can tell that they stick together because they have the same velocity when they hit. So kinetic energy is not conserved. It's a sticky collision. Position remains constant. That means the system has zero momentum, is what that means. Has zero velocity. That's what that means. And that is not true either. The position of the center of mass will happen during an explosion, but not during a collision. Velocity of the two system remains constant throughout the experiment. Yes, because the momentum of the system remains constant. If you find the center of mass of these two objects, the 4 kilogram one, it's going to be 2/3 of the way close to that, so you're 9. This is going to be the center of mass of the system, 2/3 of the way. So it's going to be 2/3 of the way like this until we get here. And then if you look at this location here, that is the velocity. Look at that. They come together and they have that same momentum afterward. If the center of mass remains constant, that must have been, that's the velocity of the center of mass. It's the velocity of all the mass afterward. So it must have been that beforehand. So you can see it, having started here, finding the center of mass and going forward, it actually confirms that confirms with what happens afterward that the center of mass has a constant velocity. Choice D.